Hello, Algebra 2 students. This is Mr. Bear, and I'm going to talk to you about some exponent properties. So I'm going to start with the ones that I'm pretty sure you're familiar with from Algebra 1. The first one is the product rule. It says if you're multiplying two things that have the same base, so like these a's, but different exponents, you keep the base the same and you add the exponents. Okay, so when you're doing a product of two exponentials, you add the exponents. Quotient rule says if you're dividing two things that have the same base, you subtract the exponents. Power rule says if you raise a base to a power and then you raise that power to another power, you multiply the exponents. Power of a power property, basically if you have power of a product property, if you have a product such as a times b and you're raising it to the xth power, each of those factors, so the a and the b, get the exponent. Power of a fraction says if you're dividing two things and raising that to a power, then you just give the power to the numerator and the denominator. And then the zero exponent property says that any value a, as long as a is non-zero, any base raised to an exponent of 0 is 1, as long as that base number is not also 0. So let's apply a few of these. On our first one, we have, this one is going to be the power of a product rule. So we're going to take that power of 3 and we're going to basically distribute it to everything here. So we have 3 to the third times x to the 4 times 3, which is 12, times y to the third. And we know 3 to the third means 3 times 3 times 3. Use a calculator, you get 27. And here's our answer for this one. For the next one, we're going to use the quotient property. So quotient property says that if you're dividing things, the 9 over 27, since those aren't exponents, I'm just going to simplify that fraction. I can take 9 and 27 and we get at the fraction 1/3. X to the fourth over x to the second. If I take 4 minus 2, I get x to the second. And y to the third over y to the second. Subtract 3 minus 2 and we get y to the first, which I can just write as y. And so this is our answer. On the next one, we're going to take the y's here and apply the the product property. Oops, went too far. Sorry, we're going to do the product property, so we add our exponents. So we're going to add the 2 plus the 5, we get y to the 7th. And then 11 and x just come along for the ride. Part D, we're going to apply a couple properties. On the numerator, we're just going to apply the product property. So 3 times my negative 4 gives me negative 12. X squared times x to the 5th, add the exponents, you get x to the 7th. Y to the third times y. Remember that y is an exponent of 1, so that will be y to the 4th. In the denominator, I'm going to multiply 8 times 2, which is 16. X times 2x, or x squared rather, is x to the third. And then I'm going to have x times, well, I don't need to worry about that, sorry, y to the third. Looking at this, 12/16, so I could simplify that to negative 3/4. For my x's, I'll have 7 minus 3, which is 4. And for my y's, I'll have y to the first. So here we go. Notice all of these so far have resulted in positive exponents. So let's talk about what happens when we have a negative exponent. Okay? So if we have a negative exponent, first of all, let's remember our quotient rule for exponents. We know from the quotient rule, if we go back up and look here, the quotient rule says we subtract the exponents. So we are going to subtract the exponents. But sometimes we have when we subtract numbers, we get a negative result. So what does that mean? Let's simplify this expression that we see below, first by just using our subtracting of exponents, and then I'm going to also rewrite the exponents as repeated multiplication. So looking at this, I know I'd take my 4 divided by 2 and I'd have 2. X squared over x to the 8th. If I do 2 minus 8, I get x to the negative 6. And then remember this y has an exponent of 1, so y to the first divided by y to the fourth. Subtract 1 minus 4, you get negative 3. So this is what the answer looks like if we let negative exponents exist. But we usually want to write these things without negative exponents. So what I'm going to do in red is I am going to demonstrate how to rewrite this problem using just repeated multiplication. So we know that 4x squared means x times x, and y just is a y. The denominator, I have my 2. I'm going to have to write x times x times x 8 times. And then my y, I have to multiply 4 times. Now keep in mind, this is not going to be the quickest way to do this, but it is going to illustrate a point. We could still see our 4 divided by 2 is going to give us 2. When I look at my x's, every time we take an x and divide it by itself, the factors cancel out. And that happens 2 times here. So my x's are gone from the numerator. I have 1, 2, 3, 4, 5, 6 x's left in the denominator. So I'm going to write x to the 6th in the denominator. I can cancel out this y with one of these down here, and I have 3 y's left over, y to the 3rd. And these two things are equivalent. So let's see what we did here. When I have a negative 6 exponent, it got moved to the denominator and became a positive exponent. When I had y to the 3rd, y to the negative 3rd, it moved to the denominator and became a positive exponent. So this feels like a rule to me. So let's put it in words, or as a rule. So now we could define a negative exponent. If you have a to the negative x, well, you need a fraction bar. You'll write a to the positive x. And since I didn't have a number other than 1 being multiplied to this, we just put 1 on top. So what do we do if we see a negative exponent? The easiest way I can think of to deal with it is to move it to the other side of the fraction bar. Okay, so let's practice that. This first one, we have y to the negative 7. So I need to actually make a fraction bar, put that y to the positive 7 on the bottom. The coefficient here is just an understood 1, so 1 over y to the 7th. For the next one, I see that c to the negative 3rd. I need a fraction bar, c to the positive 3rd now. We have a coefficient this time of 4, so 4 stays on top. For the next one, we have negative 6 q to the negative 2, so that q to the negative 2 is going to become q squared on the denominator. Negative 6 is a coefficient, it stays on top. Notice that I'm not moving a negative coefficient to the bottom, I'm just moving negative exponents. On the next one, we have a quantity raised to a negative exponent, so I'm going to write, and there's an understood 1 being multiplied to it. And then I'll have 5a quantity squared. So I'm going to now apply my product property here. 5 squared is 25. So we had a couple steps here, but that's what our answer should look like. These next two, I see a negative exponent in the denominator, so I'm going to move that to the numerator as a positive exponent. And since there's nothing attached to it, there's just an understood 1 under it. So this is just x squared. And this next one, I have 2 negative exponents. So I'm going to keep my 2 and 3 coefficients where they are. But I'm going to move the negative exponents to the other side of the fraction bar. And since I can't simplify that anymore, that's my answer. Okay. All right, this is the SAT practice problem. So when we look at this one, I want to know which of these 4 expressions is equivalent to what we have here. First thing we need to remember is if we have repeated addition, like x plus x plus x, that's going to be rewritten as 3x. And this one, same thing, another 3x. Okay, so what we end up here is 3x times 3x is 9x squared over 3 to the negative 1. And that 3 to the negative 1 is a negative exponent, so I'm going to bring it to the other side of the fraction bar and write it as 3 to the first. 9 times 3 to the first is 27x squared, so D is our correct answer.